Hello everyone. We'll try to use Slider for this talk, so you can scan the QR code and submit new questions as we go, and later I will read them and try to answer. Hope everyone interested can already scan it and open it. So in the meantime, I'm starting my presentation. And good afternoon for those who are joining. My name is Dmitry Yanter. I'm representing Berlin Technology Center of Deutsche Bank, and today I will talk about sustainable team dynamics. So what this talk is not about. It's not about CO2 emissions, it's not about green energy, renewable servers or whatever. This is about something different, and this something different is actually time. So in the title of the talk we have two words which are about time, so sustainable and dynamics. Dynamics, something that changes over the time, and sustainable means that over the time you survive and not break. So something that is changing over the time and can really survive the changes. I started in the industry 17-18 years ago, and I started with research, and I went to startup successfully failed, then I went to enterprise, and through this journey it became obvious that there is some strange dynamics of projects you work at. And I've been in Deutsche Bank for about 11 years, and if you look into projects that we have to operate, maintain, and develop, they can start from something super new up to the projects that are almost at your age, like 35 years old. And actually the whole universe and the whole portfolio of big corporate organization consists of multiple projects that live their own lifetime and their own life stage. And the tricky point is about how to navigate between the rushing rivers of the startup and when you end up in these deserts of legacy where change is almost impossible, or it's very hard to make a change. And the irony of the situation is that very often these are your projects that starts very fast, let's say very flowy, and then just freeze over the time. And sometimes it's the same team that starts very fast and then slow down, and it becomes almost impossible to deliver something big and new. And I propose here to start with a simple question, and the simple question is, how long do you think your projects will live? And I know if anybody in the audience have ever asked themselves about how long your projects will live. Any raised hands? Okay, 1, 2, 3. Not so many. I try to make some kind of, let's say, a proxy measurement for this, and I checked GitHub repositories lifetime, selected the most popular ones, and this is a histogram of GitHub repositories lifetime. So the median value is about 7 years, and if you think about it, 7 years is quite a long period of time, especially when it comes to our modern planning techniques, where we plan sprints for 2 weeks or 1 week, but in fact we are running ultra marathons. So 7 years, if you think in terms of sprints, these are a few hundreds of sprints, 200, 150. And this is where I think there is a gap. There is a fundamental gap in how there's fundamental methodological gap. So we spend a lot of time for the very first part of this picture, how to build project, how to make it happen, how to introduce nice architecture. And this is where I think we're more or less good at as an industry. So we more or less know how to launch new things. But what happens on the other side of the picture? So after multiple years passed, and I would say this life on the right side of the picture is far beyond any project planning horizons. I'm pretty sure that it's completely uncommon to seriously make plans for 7+ years. Normally, we try to plan a sprint 2 weeks. We somehow plan to plan a quarter, not perfect already. Sometimes we even seriously consider plans for years or 2 years, but this is really a planning horizon which is far beyond any methodology that we have. But the fact is that we already have quite a lot of examples where projects survived, and that's puzzling me a little bit. So how you can learn from those projects what they really do that help them to overcome these hundreds of sprints, and they still continue to develop and to deliver. I hope that by the end of this talk you'll get a little bit of insights, and I try to do it as simple as possible so that this can be actionable. However, I would say the topic itself is not quite explored on the one hand side. On the other hand side, it's not a written book where you have all the answers outlined as bullet points. So, how I approached this problem. There is a data source. It's called TAVOS. It contains almost 500,000 of Jira issues from 44 open source projects, which in total have about 3,500 sprints. There is a QR code. It's publicly available on GitHub. You can download it and make fun to check, first of all, what projects are there. And if you check, you will see some, I would say, quite famous projects. And then you can try to explore yourself and to dive into this big data set. I try to ask three questions, like what, how, and who. So what in common they do, how, what are the techniques, and what are mechanics, and who is about team, about some collective of individuals, what we can tell about what really brings the agency to develop over the time. We start with what, and as I said, it has almost 3,500 sprints, and I try to look into what is in the sprint. And this is where I would say the first counterintuitive fact comes to play, that I would say the given fact that we more or less focus at delivering something new. This is kind of like anticipation of development, software development, that we bring some new features, some new stories, and let's try to check whether it's true or not. So if we look into new features in the sprint across all those multiple thousands of sprints, it appears to be that new features are only 2% of the overall sprints altogether, which for many people is quite shocking. And there are a lot of sprints that have no new features at all. Then there is the next obvious answer, that we do not call it new features, we call it stories. And this is the distribution for stories. It's much better, 4 times better actually, so not 2%, but 8%. But this is still, I would say, marginal. It's not the biggest part of what is captured in sprint, but The biggest part of it is actually this thing, so bugs. Almost one-fourth of all sprints contains of bugs in terms of numbers, so how many issues you have here. And on the one hand side, it's obvious because we see it almost every day. On the other hand side, it's a little bit counterintuitive because we do not really think that the most common thing we do is fixing bugs. But the data tells us that here how it goes. This is I would say a static picture. I promise that there will be some time factor here, and through the talk we'll explore how it changes over the time. And on the next few slides we'll try to look how this proportion of different issue types for different projects evolve over the time. I will show a few examples. So for instance, this project, it's completed, I would say, quite impressive 150 sprints, and this is proportion of issue type that you see over the sprints. So again, the most common one is a bug. I would say that the ratio is quite stable, so there are kind of like ups and downs, but nevertheless it's more or less consistent. Obviously, this ratio itself is project specific and it can change differently. Again, this project has more than 160 sprints. Again, you can see quite significant ratio of bugs being added to the sprint, a lot of improvements, few stories, and marginal number of new features. There are some again, the dynamics can be different. For instance, in this particular case, the project primarily started with the most items being bugs, and they started to look into fixing them, and again stabilized around some value. There could be some marginal cases. For instance, this one, again, more than 100 sprints, and the project started with just one issue type suggestion, and at some point in time they introduced bugs, and again bugs stabilized around some value, and that gives an interesting insight how many issue types do you really need in your project. Some can live with just 2 or 3. So that's another interesting example. So almost 150 sprints they lived without any bugs, or at least they didn't log them, and then again they started to raise up and stabilized at some number. Interesting that if we try to look all together across all 40 projects, this will be the picture. This is the picture of let's say normalized distribution for issue types across multiple sprints. As you can see, the oldest project has more than 500 sprints, almost 600 sprints, and we can think about it just like as a metaphor. It's a kind of like a nutrition balance. If you think about nutrition, you have to somehow balance your nutrients, right? Carbs, fats, proteins, and you cannot really live the whole life with some very specific targeted food. In this case, I would also propose to think about it as a kind of a balance that is better that you follow some kind of ratio of bugs over new features over tasks, and that gives you the dynamics that actually can bring you over, not over just like a year, but years and years in the future. If I try to summarize what are the most common types, so number 1 is bug, then number 2 is task, then story, improvement, and suggestion. I would say that I would definitely expect bug being one of the most common one, story as well, task kind of like 50-50, but this improvement to suggestion that was a little bit news for me. So however, if you think about long-term planning, this picture gives you an idea how much capacity do you really have for new features. So it's quite naive to think that, like, if you have a capacity of your team of, I know, 100 story points or 1 story points per sprint, then you can afford to spend everything for new features. That's not quite true. And as you go, it becomes obvious that we tend to underestimate, I would say, the first order consequence. So because if you think about a relation between features and bugs, then actually today's release with new features introduces new bugs, and new feature of today is actually some bug of tomorrow. And this is where we tend to have a systematic underestimation error when it comes to planning, especially when it comes to long-term planning at scale of multiple months and years. For the next few slides, I will look a little deeper into these most common issue types, and we'll see how they are distributed. So this slide gives you the following. You have how many issue types are fixed, open, and closed without fix. As you already know, that the most common items that is fixed is bugs, but I would propose you to pay special attention to these ratios. So if you look into how many bugs are fixed, are closed without any fix, the number is quite significant. So it's about 31%. For suggestions, it's more than 40%. And I encourage you to be more realistic and to be quite clear that many bugs that you have in your backlog, they will be never fixed. And this is what, as an action point, you can really look into backlog and be quite honest to yourself what bugs you will never fix. The same actually applies to suggestions. As you see, we are very open to suggestion. This is the biggest open item, 31%. But we don't really close them very fast and very diligently. And this difference between the most common issue type in among fixed, its bug, and amongst open, its suggestion, is also reflected in the time that it takes to resolve it. So to resolve a bug, the median value is as small as 24 days, which is, I would say, pretty impressive. And if you go into suggestions, then the median value is 404 days, which is more than a year. That again gives us, some more realistic, and like this thing, like get more realistic can be really the motto of my talk. Be more realistic to suggestions that we have in the backlog. So many of them will not be implemented, and if they're implemented, it will take some time to do it. So let's try to summarize a little bit the first part about what. So what is common across all these long-running projects is that bugs are the most common issue type, and I would say I don't remember any of the project that has no bugs. You will have projects that have no features, no stories, but bugs are there. And another thing interesting that I find interesting is that if you look somehow generally, then there is a strategy that I would formulate that bugs are fixed quickly or never. So they are either very short-living or they are closed without any fix and kind of stays forever in the system. That gives a very interesting strategy, really to manage them, right? So you can fix it as quick as possible or just leave them forever. Okay, and let's go to the next part. We already touched a little bit into how by looking into time to resolve the issues, and in the next section I will try to quantify this how, i.e. to quantify the contribution of different team members. And in order to do this, I clusterized all the assigned issues, so contributors. So if I have, for instance, if I'm a contributor, I contributed 25 story points in total. If my friend is another contributor and he contributed, I don't know, 500 or 5,000 story points, this I try to clusterize our contributions, and this is the picture. So again, there are quite a lot of contributions, and the I would say the data set is quite rich, and we can identify two most significant clusters. So the one cluster is top contributors, so these are contributors who really they are really outstanding, and we have a lot of new contributors, and this is, I would say, the clusters that becomes very obvious when you look into the distribution, and like everything in between is something in the middle. So I don't really have a good word for it. So I will call new contributors that contributed not so many issues, not contribute not so many story points, and then top performers who contributed a lot. And this is an interesting fact I find, that if you try to compare the overall contribution from different clusters, i.e. how many story points new contributors added to the project versus top contributors added to the project, you can see that I would say in general the contributions are very comparable. Yes, top contributors make more, however not really significantly more. So I would say they are a little bit at par. But then there is the next, I would say, shocking number, is that if you compare how many story points top contributor on average brings to the project versus new contributor on average brings to the project, the difference is more than 500 times. And that's a little bit like wow factor, because it brings you and gives you two fundamentally different strategies how you can evolve. You can either rely on a broad network of new contributors, or you can make this take and develop the project with your top performers. And formally speaking, from like game theory, these are two extreme strategies. And if you look into the overall results, the results are very comparable. So I think to bring your project to the state where you can easily encourage new contributors to come in, it's not very trivial. You have to make a constant engagement. You have to make sure that it's really easier to contribute to a project. The other strategy, to rely on top performance, I would say it's quite natural, because many projects, they start with a small team who really started to develop it, and they contribute over and over the time, and the setup of, for instance, 2 or 3 people being the top contributors and really moving the project forward is quite natural. However, there are some drawbacks, and on the next few slides I will look into dynamics for this top contributors cluster, how it grows over the time. So here on the slide you can see for particular contributors how actually everything is normalized to not take care about number of story points, scaling of time, and so on and so forth. This is how contribution of this top performance evolves over time. And what is interesting that if you do some math around it and try to find the second derivative, i.e. if you're trying to find how fast the speed changes, you will find that second derivative is normally negative, which means that it slows down over the time. So contribution slows down over the time, and I would say it's quite a consistent pattern across the data set. So your top contributors, they bring the most value to the project. However, as time goes by, they tend to slow down, and that's an interesting. So it's not like surprising news, right? So probably we all know about bus factor, but this is really the time factor. As you go and as you contribute to your project, as you develop, then you tend to slow down. And personally, you can easily explain it. But if you try to think how your team evolves and how projects evolve, then I would say this factor doesn't get enough attention. So on the one hand side, top contributors, they are super performant and can deliver 100 times more than new contributors, but on the other hand side, they slow down with the time. And then we're going to the next section and try to a little bit balance these two extreme scenarios. So, and for the next section, I'm trying to answer question about who question, and this is a question about actor, or if you go into like philosophical term, that is subjects, i.e. the conscious being, like the what holds the agency for the change, either the team, an individual, a collection of individual, and how the structure works. And in order to do this, I propose to build I call it just project network. So for instance, you have a Jira item, and this Jira item has a reporter, developer, assignee, and they build a graph with 3 nodes, 3 edges. Very simple. If I have another Jira, like here, I have a new person, they change their roles in the Jira, but nevertheless they build the graph. And I did it for all the projects in the data set, and this is actually how it looks like. So you can see that the projects, they are really very intertwined. They have a lot of connection between the members, and in this particular one, you would probably see even the top contributor in the very center. They have the biggest number of connections, and the project is centered around them. On the one hand side, it's an interesting side. On the other hand side, think what will happen with the project if we just take this dot out. Maybe it will survive, maybe not. But I like more this one. So this is another network diagram, and it's really looks like a wired brain. So very centered, so very dense, with a lot of connections between all the neighbors. And if you make this mental exercise to take out one of the nodes, probably the network will survive. So there is no reason why it should fall if you take out one of the nodes. Obviously there will be some perturbations, rebalancing, and so forth, but it really looks more sustainable. Interestingly, if we look into some young projects, then they may look like here, like this. So they are built around one person, and one person is mostly interconnected with everybody else, but other, let's say, other layers of the network, they are quite isolated. The fact is, if you try to look for all these scenarios, there is really a statistically significant trend that projects tend to move from left to right. Again, if they survive, then they will be quite wired, or they will die somehow in the middle. So to sum up about sustainable team dynamics, I just try to put two simple rules about don'ts. Don't rely on star performance, because it slows down with the time and it builds really not sustainable structure. And again, this is a real example, so this is not just imaginary one. One of young projects is lived like here, and it doesn't really sound sustainable. And given that we know that most projects who survive, they evolved into something more complicated, then in section do's there are two simple rules, like fix bugs and build networks. As simple as that. This is it. Any questions? In the meantime, I will try to work with the questions. So the first question: what was the set of projects that you used as data for this presentation? So I took the data set from the very third slide, I think, and actually it was all the projects from that from the data set. You can have a look. I can actually go back to the picture with QR code. Yes, you can check it out. So it's GitHub link, and you can see what are the projects there. I hope I answered the question. Okay, then the next one: wouldn't be expected that all teams, including the top performance, to slow down with time due to the complexity of the project? I would say yes, it would be expected, and it would be expected if you think about let's say every individual. So as they go through this curve, they tend to slow down. However, the project itself can really even speed up if the project can engage more people. And this is a little bit counterintuitive, that every contributor tends to slow down. However, if you can engage a lot of people, your project can speed up. And if you think about team as something static, then yes, it slows down. If you think about the team as like a collective of individuals who work at this particular task, then delivery, then not. But it happens with new people joining the team. Okay, which tool did you use to visualize the data? It's Python and whatever, matplotlib, and you can go through all the fun thing. I assume that these were all open source projects. How would things translate to commercial non-public projects? Well, that's I need to find the right words how to answer this. Uh, I would say that I tried to do similar metrics, and sometimes what really helps is to bring this network diagram. I would say it's quite easy to build. Where is it? So these network diagrams, they're super easy to build. Actually, you just need to extract all your JIRAs to get like reporter, assignee, developer, analyst, or whatever field you have, and try to bring this picture into life and try to see it. And I would say it may give you a very good insights, because very often you will see something like on the left hand side where the project actually is built in this sense around one to people. And this is what you have to think about, whether you are fine with this situation or not. Okay, have you done the same analysis to your society projects? I did similar thing to a project that I work at professionally, and that was what I did for that network diagram I built. And that gives insight about how you actually have to rebalance, let's say, rebalance skill sets in your team. And sometimes you have to let's say, a little bit de-risk, I would maybe the right word here. So sometimes you intentionally need to ask people to work on, let's say, nearby components, or try to engage new people from other projects, or try to not to be in the state that the whole team is driven by one person, and becomes very obvious when this person goes to sick leave or vacation that everything is slowed down, or people do not know what to do. So in this sense, I tried to build this network diagrams, and these were quite, I would say, quite insightful. What are the reasons for the top performance to slow down over the time? Well, unfortunately, I don't know. So this is what data tells you, that this is just a fact. It slows down. Reasons to make the proper reason analysis and factor analysis, I would say techniques are absolutely non-trivial, and it's hard to make conclusions which are reliable enough. Okay, could you explain what the meaning of the edges in the graphs? The vertices are the people, correct? Yeah. So on the graph, the edges, and I will go to this slide. So vertices or nodes are people, and edge means that, for instance, in this case, these three people were part of one JIRA. So actually, they are part of one JIRA item, and this puts the edge. I hope I answered the question. Yes, no? Okay. Okay, and this one, unfortunately, I cannot really understand. If serialization, yeah, okay, that's fine, that's good. All right, nothing else in Slido. Any other questions? Just raise your hand. No. Then thank you very much. Thank you much, and have a nice afternoon. Thanks.